Download this code from codegive.com, link in the description below. OK, let's dive deep into the significance of join and isalive functions in the context of multithreading, particularly within Python's threading module. We'll cover their purpose, how they work, and why they're essential for robust and well-behaved multi-threaded applications. We'll also include illustrative code examples. Part 1, Understanding Threads and Their Life Cycle. Before we can fully appreciate join and isalive, we need a solid foundation on threads and their life cycle. What is a thread? A thread is a lightweight, independent unit of execution within a process. A process can have multiple threads running concurrently. Threads within the same process share the same memory space and resources, which allows them to communicate and collaborate more efficiently than separate processes. Benefits of multithreading. Improved responsiveness. A long-running task in one thread doesn't block the user interface, UI, in another thread. The UI remains responsive. Parallelism. With caveats on multi-core processors, threads can truly execute in parallel, potentially speeding up certain tasks, especially CPU-bound tasks. Note that Python's global interpreter lock, GIL, limits true parallelism for CPU-bound tasks in many cases. The multiprocessing module is often a better choice for that. Resource sharing. Threads within the same process can easily share data and resources. Simplified programming. For certain tasks, example handling multiple network connections, multithreading can simplify the program's structure. Thread states. Threads typically go through a life cycle with these states. New. The thread is created but hasn't started executing. Runnable. The thread is ready to run and is waiting for the operating system to schedule it. Running. The thread is currently executing. Block/waiting. The thread is waiting for a resource, example a lock, IO completion, another thread to finish. Terminated/dead. The thread has finished its execution or has been terminated abnormally. Part 2, the join method, waiting for thread completion. Purpose. The join method of a thread object is used to block the calling thread, usually the main thread, until the thread on which join is called has completed its execution. How it works. When you call thread.join, the calling thread will suspend its execution and wait until thread has finished running its run method, or the target function passed to the thread's constructor. Significance. Synchronization. Join provides a crucial mechanism for synchronizing threads. It ensures that the main thread, or another thread, doesn't proceed until a specific background thread has finished its work. This is essential when the main thread relies on the results of the background thread. Resource management. Join can help ensure that resources used by the background thread are properly cleaned up before the program exits. If a thread is still running and holding onto resources when the program terminates abruptly, you could encounter issues like data corruption or resource leaks. Order of execution. Join allows you to control the order in which threads execute and complete. You can ensure that certain tasks are completed before others begin. Preventing premature exit. Without join, the main thread might exit before background threads have finished their work, potentially leading to incomplete operations or errors. Syntax. Timeout, optional, specifies a maximum waiting time in seconds. If the thread doesn't finish within the timeout, join returns. If timeout is none, the default join will wait indefinitely. Asterisk code example asterisk. Explanation asterisk. 1. We create 3 worker threads, each running the worker_thread function. 2. We start each thread using thread.start. 3. The main thread then iterates through the threads and calls thread.join, for each one. This causes the main thread to wait until each worker thread finishes its execution, the time.sleep in this case. For only after all the worker threads have completed does the main thread print the final message. Without join, asterisk if you comment out the thread.join calls, the main thread would likely print main thread, all worker threads have completed, before the worker threads have actually finished. This is because the main thread would continue executing without waiting for the background threads to finish. Asterisk timeout example asterisk. Explanation asterisk. Asterisk the worker thread sleeps for 10 seconds. Asterisk the main thread calls thread.join, timeout equals 5, which means it will wait for a maximum of 5 seconds. Asterisk since the worker thread takes 10 seconds, the join call will time out. Asterisk the code then checks thread.is_alive, to determine if the thread is still running. In this case, it will be. Part 3, the isalive method, checking thread status. Asterisk purpose asterisk. The isalive method of a thread object returns true if the thread is currently running, i.e., it has been started and has not yet completed its run, method or target function, and false otherwise. Asterisk significance asterisk. Asterisk determining thread state asterisk isalive is a simple way to check the current status of a thread. You can use it to determine if a thread is still working, has finished, or has been interrupted. Asterisk conditional execution asterisk you can use isalive in conditional statements to execute different code paths based on the thread status. For example, you might want to avoid trying to access data that a thread is still writing to. Asterisk resource management asterisk isalive can be useful in situations where you need to decide whether to clean up resources associated with a thread. You might only want to clean up resources after the thread has finished running. Asterisk timeout handling asterisk as demonstrated in the join timeout example, isalive is often used in conjunction with join and a timeout to handle situations where a thread might be taking too long to complete. Asterisk syntax asterisk. It takes no arguments. Asterisk code example asterisk. Explanation asterisk. Asterisk we create a thread but don't start it initially. Thread.is_alive returns false. Asterisk we start the thread. Thread.is_alive now returns true. Asterisk we wait for a short time. The thread is likely still running, so thread.is_alive remains true. Asterisk we call thread.join to wait for the thread to finish. Asterisk after the thread has finished, thread.is_alive returns false. Part 4, Common Use Cases and Best Practices. Asterisk waiting for background tasks to complete asterisk this is the most common use case for join. When your program relies on the results of background threads, you must use join to ensure that those threads have finished before you proceed. Asterisk graceful shutdown asterisk when your application is exiting, use join to wait for all background threads to finish their work before the application terminates. This can prevent data corruption or resource leaks. Asterisk thread pools asterisk in thread pool implementations, join is often used to wait for all threads in the pool to complete their assigned tasks before shutting down the pool. Asterisk progress reporting asterisk you can use isalive in conjunction with a progress indicator, example a progress bar, to update the UI while a background thread is working. The main thread can periodically check isalive and update the UI accordingly. Asterisk error handling asterisk if a thread encounters an error and terminates unexpectedly, you might use isalive to detect this situation and take appropriate action, example log the error, retry the task. Asterisk careful use of timeout asterisk use timeouts with join, to prevent your program from hanging indefinitely if a thread gets stuck. Handle the timeout situation gracefully. Asterisk exception handling in threads asterisk ensure that your threads have proper exception handling. If an unhandled exception occurs in a thread, it can cause the thread to terminate abruptly, which might lead to unexpected behavior in the main thread. Asterisk avoid data races and deadlocks asterisk when multiple threads access shared data, use proper synchronization mechanisms, example locks, semaphores, to prevent data races and deadlocks. Part 5, example, downloading multiple files. Here's a more complete example that demonstrates how to use join, and isalive, in a practical scenario. Explanation asterisk. Asterisk the download underscore file function downloads a file from a given URL. Asterisk the main function creates a list of URLs and corresponding file names. Asterisk it creates a thread for each URL, starts the threads, and then waits for all threads to complete using join. This ensures that all files are downloaded before the program exits. Key takeaways. Asterisk join is essential for synchronizing threads and ensuring that the main thread, or other threads, waits for background threads to finish their work. Asterisk isalive allows you to check the current status of a thread and execute code conditionally based on its state. Asterisk use timeouts with join, to prevent your program from hanging indefinitely. Asterisk handle exceptions properly in your threads. Asterisk be mindful of data races and deadlocks when multiple threads access shared data. By understanding and using join, and isalive, effectively, you can write more robust, well-behaved, and predictable multi-threaded applications. Remember to consider the specific needs of your application and choose the appropriate synchronization mechanisms to ensure data integrity and prevent race conditions. Good luck.